Hello guys, welcome to my YouTube channel. In this video I am going to explain you about the singular value decomposition problem. So here I have given me the matrix A. So it is 3 cross 2 matrix. So these are the steps that we have to follow. So there are total 5 steps that you need to follow. First we will calculate A transpose A matrix and we will calculate its eigenvalues and eigenvector. Okay, then we will find the normalized vector of A transpose A matrix, so we name it as V. Similarly, we will find the normalized vector and eigenvalues of A transpose matrix. Okay, so at last how we will get to know that whether we have solved the problem correctly or not. So at last we will take A is equal to U summation V transpose. So this is the U matrix that we have already found here, and this is the V matrix that you find here. So we'll take transpose and we'll calculate the summation at the last. I will tell you about that, so please stay connected. So first here we'll calculate A transpose A. Okay, so this is the A matrix. We'll calculate its transpose. Okay, so I hope that you know how do we calculate the transpose. Okay, so this is the A transpose matrix here. This is the A matrix, so we'll multiply it. So after multiplying and adding the values, so I have got it as 3 and 3. So this is 2 cross 2 matrix here. Okay, so to calculate the eigenvalues and eigenvector, so it is the method here we have to follow it. A transpose A minus lambda I, we will take its determinant. Okay, and we have to equate it to 0. So after doing the determinant here, so I have got it as 3 minus lambda into 3 minus lambda. This is 3 lambda square minus 3 into 3. This is 9 is equal to 0. Okay, so I will solve it as A minus B whole square. This is 3 square plus lambda square minus 6 lambda minus 9 is equal to 0. Okay, so here I have got lambda square minus 6 lambda is equal to 0. Okay, so we'll factorize it. This is lambda into lambda minus 6. So I have got here two values, either lambda is equal to 0 or lambda is equal to 6. So we will calculate the eigen values and eigenvector through two different values of lambda. First we will take lambda is equal to 6. You can take 0 also. So I have taken here 6. So this is the generalized form of 2 cross 2 matrix when we calculate the eigenvalues. Okay, so I have written it in the generalized form. So A11 minus lambda, A12, A21, A22 minus lambda. This is the eigenvalues that we have assumed here. Okay, so we have to equate it to 0. So I have put it for lambda here, lambda is equal to 6. So as you can see, 3 minus 6, 3, and after that when we will calculate it, you will get it as later on minus 3, 3, 3, minus 3, and this is x1, x2. So we'll do the cross multiply. We'll do the matrix multiplication simple. Minus 3 into x1 is minus 3x1, and 3 into x2 is plus 3x2. Similarly, we will take the second row. 3 into x1 is 3x1, and this is minus 3 into x2 is minus 3x2. We'll equate both to 0. Okay, so as you can see here, both the matrices are same. Okay, both the equations are same. This equation and this equation are same. Okay, so when you will equate x1 and x2, here you will get x1 is equal to x2. Okay, yes. So we will assume here, as we have got both x1 and x2 same, we will assume x2 is equal to 1. Okay, we will get as x1 is equal to 1 also. Okay, yes. So we will calculate the eigenvector here. Okay, we have already got x1 and x2, so these are only the eigenvectors. Okay, for case 1. Okay, for case 2 we have got lambda is equal to 0. So I will put in the generalized form that I have shown you previously in the previous page. Okay, so 3 minus 0 and here is 3, and here is also 3, and when you will do the matrix multiplication, you will get the two equations here. 3x1 plus 3x2 is equal to 0, and 3x1 plus 3x2 is equal to 0. Okay, so as you can see here also, both the equations are first you will check. 3 into x1 is 3x1, and here 3 into x2 is 3x2. Yes, both the equations are same. So what we will do here, when you will equate x1 and x2, you will get x1 is equal to minus x2. Okay, you take any one equation. Both the equations are same, you take any one. So you have to assume any one value. Okay, I will assume x2 is equal to 1. Okay, why I have assumed x2 is equal to 1? Because it will make my calculation simple. So I have got x1 is equal to minus 1, because I will put x2 is equal to 1, so this is minus 1, so I will get x1 is equal to minus 1. So similarly here, eigenvector corresponding to lambda is equal to 0 will be, as already I got x1 and x2, I will put the values here in the vector form. So I got the eigenvector corresponding to lambda is equal to 0 as minus 1 and 1. Yes. So here, after calculating the eigenvectors corresponding values of lambda, we have to write them in the normalized form. Okay, so first we will normalize the eigenvector. Okay, we will write for lambda is equal to 6 here, and for lambda is equal to 0 here in this column. So normalized eigenvector is what? Okay, it is for every column, okay, of the normalized eigenvector. For every column you have to put in denominator square root and add both the terms. Like here I have got 1 and 1, so I will put square root of 1 square plus 1 square. So I have got square root of 1 square plus 1 square is what? This is 2. Okay, similarly here also you have to put, and for this row again it will be again square root 2 only. Okay, yes. Now we will calculate the eigenvalues and eigenvector for this form, I mean A transpose. Okay, so previously we calculated for A transpose A. So here we will do the simple matrix multiplication and addition. Okay, I hope you all know it already. If you have any doubts and confusion, you can let me know in the comments. I will make any video over it. Okay, yes. So here I have written the generalized form for 3x3 matrix, and it's for the different lambda values. Okay, so this is x1, this is x2, this is x3. Okay, so eigenvalues of matrix A transpose is equal to 6, 0, 0. As previously we got 6, 0, so the rank of the matrix A is 2. Okay, so if the rank of the matrix is 2, so its eigenvalues will also be 2. Sorry, it will be here for A transpose we are getting the 3x3 matrix, so that's why we have to take the third value as 0. So lambda is equal to 6 here. For case 1 we will take again here in A transpose matrix. Okay, so diagonal values we have to take minus 6 here because we have to subtract the lambda value. So after doing the subtraction and all, you will be getting here minus 4 this, and you will multiply it with it. So minus 4 into x1 is minus 4x1, this is 2 into x1, x2 is plus 2x2, and 2 into x3 is 2x3. Similarly, for when you will calculate for these, okay, you will find here, okay, these all three equations are different. Okay, when you are getting this type of case after multiplication, you are getting three equations different. You take any two equations. I have taken here equation 1 and equation 2. Okay, I have just taken 2 common out here, and it have come like this. Okay, so here I have written the equation 1 and equation 2 again. So minus 2x1 plus x2 plus x3 is equal to 0. x1 minus 2x2 plus x3 is equal to 0. So how you will calculate the values of x1, x2, x3, I mean these eigenvectors, how you will calculate the eigenvector x1, x2, x3. So you just write it down, x1, x2, x3 and x1 again. Okay, then you write the x1 value just below the x1 here. Okay, so I have of equation 1. Similarly for x2 you will write it here, x3 here, and again you will write x1 here minus 2, which is here. Okay, similarly for this equation you will also write it again like this, 1 minus 2, 1 and 1. Okay, so then to calculate this x1 value, we are doing taking the use of the multiplication method. Okay, so x1 by, so for to calculate x1 I will put it like this. So this row is this column is hiding. Okay, yes, so you have to take the adjacent rows and columns into the mind. Okay, and you just calculate like we calculate the determinant. Okay, so x1 by 1 into 1 is 1. Okay, minus is here. Okay, so this is minus of minus 2 into 1. Okay, similarly for x2 you will calculate it as 1 into 1. Okay, minus of minus 2 into 1. Similarly for x3 we will take help from these two rows and these two columns. Okay, this is minus 2 into minus 2 minus of 1 into 1. So at last you will get here the values of x1 and x2. Okay, so and x3 you will get the values at 1 comma 1 comma 1. Okay, so similarly for case second, when you will put lambda is equal to 0, you will be getting the eigenvalues and eigenvector as. So this is the eigenvector for lambda is equal to 0 in the matrix A transpose. Okay, x1 x2 which is equal to minus 1 1 0. Yes. So for case 3, so this is the special case here. Okay, as this is 2 cross 2 matrix, so there is its rank is 2 only. So for calculate the third value, we have to take use of the orthogonal property. Okay, so x3 will be equal to the third vector will be equal to, we'll assume it as ABC. Okay, this is the orthogonal property. X1 transpose x3 is equal to 0. So x1 transpose, the previous value we calculated in A transpose here. Okay, in the case first and second. Okay, this is x1 value, x1 vector, and this is x2 vector, eigenvectors. Okay, we will take the transpose and we'll multiply separately with x3 that we have assumed, and we'll equate it to 0. Okay, so as you can see here, I have taken the transpose of x1. Okay, this is 1 1 and 1. When you will multiply it with it, you will get a plus b plus c is equal to 0. And similarly here, you will take the transpose of x2 and you will get it as minus a plus b plus 0 is equal to 0. Okay, as I told you, when you have the two different equations, how you can how you can calculate the values, three different values. So similarly, we will take help from here. Okay, I will write a, b, c and a. Okay, I will write 1 1 1 1 of equation first. Okay, yes, similarly you write the corresponding values of a, b, c and a from equation this, minus a plus b plus 0 is equal to 0. So as you can see here, I have calculated by the cross multiplication that I told you in the previous step only. So here I have got the third eigenvector as minus 1 minus 1 2. Okay, so now I will normalize it the same way as I have normalized the eigenvector v in the previous step. Okay, as you can see here, I have written it directly now here. So I have got it actually here 1. Okay, and this is 1 1, that is case 1, this is case 2, and this is case 3 here. Okay, minus 1 2, minus 1 2 is here. Okay, I will show you for this third column how I have calculated. I have calculated as, let me show you. This is minus 1 square, sorry, this minus 1 square plus minus 1 square plus 2 square. So when you will calculate its square, minus 1 square is 1, 1 plus 1 is 1, 1 plus 1 is 2, 2 plus 4 is this is 2 square. So 4 plus 2 is what, 6. This is square root of 6. Similarly for this, I have here in this column I have got square root of 6. So here I have minus 1 and minus 1. When I take the square of minus 1 square and 1 square, I have got it as square root of 2. Okay, so this is the last step. As we already calculated eigenvector for A transpose A into A transpose, and this is the A transpose A V that we both already calculated. So I have written it here again, once again. So this is the summation of the matrix, that how we calculate it. So we have to take consideration the matrix multiplication, the conditions. Okay, so here U is 3 cross 3. Okay, so summation should be either it should be number of so this is number of rows and this is number of columns. So number of columns of this matrix, next matrix, number of rows of next column should be equal to number of rows columns of the first matrix. Okay, so here either it should be 3 cross 2 or 3 cross 3 for the summation matrix. So this here you have to only write the first values. Okay, so the first A11 element is always equal to square root of sum of the eigenvalues. So we have got 6 comma 0 comma 0. Okay, so when you will take the square root of summation of the eigenvectors, eigenvalues, you will get it as square root of 6. Okay, so I have to write it as 3 cross 2 matrix into then V matrix is already what, 2 cross 2, as you can see in the previous section, as I already showed you. Okay, so when you will multiply this matrix with this, you will get it as 3 cross 2 matrix. Okay, here you have 2 cross 2 matrix. Okay, yes, so when you will multiply it, you will get it as 3 cross 2 matrix. So the given matrix A is 3 cross 2 only. Okay, so by doing the calculation from your end, you should be able to get to know that the matrix summation, whether I have to take it as 3 cross 2 or 2 cross 3. So if the given matrix is 3 cross 2 A, okay, then summation should be also 3 cross 2. If it is given 2 cross 3, then in the later stage summation you should take 2 cross 3 only. Okay, I hope the problem is solved now. So Vt is a transpose of V matrix, so I have taken the transpose here. Okay, so from RHS we will take U matrix here, and we will take the summation matrix here. Okay, so I will do the multiplication of here. As you can see, I have done 1 by root 3 into root 6, so I will get it as root 2. So these two elements, when you will multiply with this, we will be getting at 0. Okay, so similarly, if we will take this row, okay, we will multiply it with this column. Okay, we will get it as root 2, because for other elements you will get a 0, we will take the sum, and for this column it will be again 0. Okay, so when you will multiply this with this matrix, you will get it as root 2 into 1 by root 2 will be equal to 1. Okay, similarly this into this will be equal to plus 0. Okay, similarly we will take this row and we will multiply it here. This is 1 plus 0. Okay, similarly this will be again. So we have got it as equal to left hand side. Left hand side is our A. So if you will check, so as you can see here, our given matrix is A, which is 1 1 1, and the solution that we have got at the later stage, it is 1 1 1 and 1. Okay, so our problem is solved. If you have understood the problem well, so please do comment in the below, and if you have liked this video, please share the video to your friends, and stay connected and subscribe to my YouTube channel. Okay, thank you for watching.